How do you use this? I guess I have to click here and then, well, and then it's time for us to do our notes for today. Okay, what we're going to be doing is talking about the first day of 2.3 function composition. And I figured since this is Halloween week, this would be the right way to do it. So let's go with your favorite Asgardian and talk about function composition. Okay, so this is a little bit of a longer lesson because we've got a couple different ways of looking at it. But ultimately, the word that I want you to think about when you're thinking about composition is basically the idea of combining two or more functions. Now, for what we're going to be doing here today, we're going to be combining two functions because it's a lot easier to do that. But essentially what you're doing is you're taking the rules from one, inputting them into those rules, getting out an output, and using that then as the follow-up to be able to get an output for another function. So it kind of looks like this. If you're looking here, essentially what you're going to have is we start talking about starting with an input, plugging it into the first function f. Once we do that, you're going to get an output. That then gets plugged into another function g, and then kicks out a final output for our entire composed function. So with that being said, it's a little bit weird the way that this looks, but essentially what you're going to be doing with this is you are going to have two functions, and you're going to work from the inside out. And the reason I want you to think about that is because generally at the beginning of this, what we're going to be doing is taking these functions and working, starting on the inside parentheses with the very first input and then working our way outside. So in the case of doing something like this, it essentially means if we're going to be doing this with the way this is looking, if I have a function f that's f of x, and then I have a function g, since this is going to be getting plugged into, since the output of this, let's say f of x is going to give us, we'll go a. All right, that's the output that we have here. We're then going to plug that into g, and that's going to give out our final output, which we'll call y. So essentially, f of x gives us a, g of a gives us y, so it combines the two things. But when we do this, there are a couple of ways that could look. The first way that we're going to be looking at that is called nested function notation. And what this is the idea of writing both functions with one put inside of the other. Now, we haven't done a whole lot of this when we've been evaluating functions, but the general idea is that anything that is set inside this set of parentheses can be an input. So what I'd like to have us look at is two separate functions that we can deal with. We have f of x equals 2x plus 7, and then we have g of x, which we can call 4x minus 3. Now, we did really simple functions because we didn't want this to be anything that looked confusing. When we're going to be doing the nested function notation, it means that we have one put inside of the other. They're called nested because they're like nesting dolls where one's inside of the other is inside of the other. And so in this case, we've got two functions nested. Since we're going to work from the inside set of parentheses out, that means the first one we're going to be evaluating is our g. We'll get our answer from that. Then we'll plug that answer into the f on the outside of this. So it's giving us a question of finding the value of f of g of 3. So when we look at this, before I do anything, I want you to look at the inside and see the very inside of this is 3. And that means that the input value we're going to be using is that 3 right there. Okay, so we're going to be starting with this. So your step one is to start with the inside function first, which is g of 3. Now, we know from what we have up here, g of x is 4x minus 3. So g of 3 means I take 4, I plug that 3 in instead of x, 4 times 3 minus 3, and we're going to do the work here. So 4 times 3 is 12, minus 3. 12 minus 3 gives us an output of that interior function as 9. So when we look at something like this, the general idea of what we're going to be doing is to get out our number here. So far, we had, and I'm going to do this kind of off to the side in maybe a different color. When we have f of g of 3, we evaluated this inside, g of 3. We got the answer of 9. And so I'm going to replace that right here with a 9, but I still have that function f on the outside. So since we're taking that output there, I'm going to be doing that, plugging that in right here, f of 9. And now, because it's the f, I use the rule that we had up here for our f of x, 2x minus 7, but I'm going to be plugging this into that. So at this point, we're going to be doing 2 times that input 9 plus 7. We know that 2 times 9 is 18, and 18 plus 7 will give us a final result here of 25. So when we're done with that, we know that f of g of 3 at the end of all of this work is going to give us 25 as a final output for this. Now, this isn't supposed to be something that's overly difficult. The idea behind it is just to know that you have to go with the steps, working with the inside and working our way out. And that's kind of the way that this is supposed to work. So nested function notation is what you're going to see most often, is having two functions set inside of each other. They'll define the two of them, and then they'll have you plug them in this way. Now, when we move to the next page, there is a different way of looking at it. And this is called composition notation. And so what this looks like when you're looking at composition notation, what they do is they put the two functions and tell you what you're dealing with here. And they have this little open circle on the inside here. Now, it's just kind of a shortcutted way of saying exactly the same thing we did with the nested one. I kind of think of this word here, this open circle here, to work as the word of as we're looking at this. So this is f of g of x. And I wrote that here as well. But when we're doing this, this means it represents exactly the same idea if we wrote it in nested format. And ultimately, the problem is there isn't a really great way of doing this and having it look, I guess, different. Our first step is always translating our nested function our composition function into function notation. Because when it's written this way, it's harder to see what's inside and what's outside. So if I have this composition f of g of 6, I need to write it in nested notation so that now I know I'm going to be evaluating this g of 6 first. Okay, so with that being said, g of 6 is what I'm looking at. And when we think about what we had, it's the same two functions we had on the previous page. So it's 4x minus 3 is our g function. We take that 6 and plug it in here. 4 times 6 minus 3. That's going to give us 24 minus 3, or 21. So now we are going to be taking that as the input for our function on the outside. So this will be f of that 21 that we have right in there. That is going to be our new input. So our 21 goes down here as the input for our final function. And now we take it as the 2x plus 7. So 2 times 21 plus 7 will be 42 plus 7, or 49. And so our final answer for this one of f of g of 6 is going to be 49. Now, again, the reason why we call this a composition is because when we're doing this, we're going to be combining more than one function at the same time. And so what I want you to look at in the way that some of these exercises below are sort of written is I want you to look at the way that they have them composed. Because if you notice, they give you what the two functions are at the beginning. One of them is a quadratic. We have x squared minus 5. So we're going to be doing some stuff with exponents. And here 2x plus 3 is just a straight up linear like the ones that we've had before. What I want you to notice, though, is that some of these, like f of g of 1 and g of f of 2, they're just like the two examples we had. We've got two different functions. You plug it into one, plug it into another. But I want you to notice you can compose the same function twice, g of 0, or here, f of 1. And so it doesn't matter the way that you do it. As long as you're using a function more than once, you can compose new functions by using whatever you'd like to. And this is the way that we combine them. You could do a bunch of these nested, g of f of g of f of 6. We're never going to make you do that, but it is a way that you could go about doing this. So what I'd like to do is I'm going to go through about maybe 3 of these to sort of show you what this is going to look like in a little bit of a different way. So we still have these two functions here. F of g of 1, I'm going to start with that first one first. And to say, as we're doing this, we start from the inside. So 1 is my input value. And I'm doing this inside the g function. So this is going to be g of that 1 that we're looking at right here. So the first thing that I do with this is say I'm doing the inside. I look up to the g function here. It's 2x plus 3. Now, what we learned about when we're going to be evaluating these functions is you replace the x with parentheses, and then you plug the input from here into the place where the x was. So now I'm going to be doing the work 2 times 1 plus 3. Now 2 times 1 is 2, plus 3 gives me an output here of 5. So now what I'm going to be doing is taking the outside of this function. it's f of, now we just found out that the g of 1 turned into this 5. So now I'm going to be doing f of 5. It's not too difficult, but you do have to recognize what we're doing here. Now, I didn't have the f on the outside of this because we took it from before, but it does give us a place of looking at it. So now that we do this, if it's f of 5, we're going to use the function x squared minus 5. So parentheses squared minus 5. And because my new input is this 5 here, I'm going to put that right here in the parentheses. Now I've got 5 squared minus 5. Okay, we got to do the exponent first. 5 squared gives us 25. And 25 minus 5 is 20. So at the end of this, f of g of 1 is going to give us an output of 20. And that kind of tells us what we're going to be looking at. Now, guys, that is a little bit complicated in terms of the amount of things we've had to do for it. But again, it's just making sure you know what number goes in where. And that's what most of what we're going to be doing is going to look like for this section. I want to move down to this guy down here, the g of f of 3, because I think it's going to be a little bit more space, and then I'll pop up to this last one up here. So if we're going to do g of f of 3, my first thing that I'm going to do is going to be to work my way in writing this as a translated function. So g of f of 3. And I do these different colors to sort of show 3 is my input. I'm going to be doing the f function first, and then I'm going to be doing the g function second. We work from the inside out. Same as 2 equations that we used before. We're going to be doing f first this time, though, so that's on the inside here. So if I'm going to be sliding this up and doing the f of 3, then the equation itself is going to be x squared, or in this case, parentheses squared, minus 5. And we know from this input here, we're going to be plugging 3 in for that input. So let's do some work here. 3 squared is going to be 9, and 9 minus 5 is going to be 4. That gives us the output value that we have for this first interior function. Last thing that we're going to do then is to take that and put it into the g function that we have here, because we've just evaluated the f of 3, and this is going to go right there. So now we're going to do g of 4, which is going to give us, well, our equation up here says 2x plus 3, so 2 parentheses plus 3, and that 4 is what we're going to be putting right in there. So we're going to have 8 plus 3, or 11, as our final answer for this. And we can put that right up here. The g of f of 3 is 11. Last thing that I want to do is to compose a function with itself, because I think it is a little bit easier to see what it is that we're doing. I'm going to use the function g because I think it's probably easiest. And so when we're doing this, the first thing that I need to do is this interior part, which is the g of 0. Now, I love 0 as an input value because most of the time what it's going to be giving you is something that is easy to evaluate. We're using that 2x plus 3 for both of them. So first thing we're going to do here is go 2 parentheses plus 3, and I'm going to take this input and plug it right in there. 2 times 0 plus 3. Now guys, anything times 0 is 0. So 0 plus 3 is going to give me 3 as an output for that interior function. Now that means that my next part of this is to take the secondary g on the outside here and plug this 3 in right here, because the output from the first function is the input for the second. And now the work is remarkably similar. 2 parentheses plus 3. We take that input and put it right here, and then we do the work. 2 times 3 is 6. Plus 3 again is going to be 9. So the final output for g of 0 is going to be 9. And I think in terms of giving you guys a good flavor for what it looks like to do this sort of composition of functions with input values, this is probably a pretty good summary of the way that that's going to work. So with that being said, I am going to stop sharing and say to you guys, that seems like it's enough for me. And so I wish you guys good luck as you move forward in your adventure at composing functions.